Hi there. Joseph Kursky here with you now. I used to work at the U.S. Geological Survey, and there's a service that the USGS and the Smithsonian operate called This Dynamic Planet. And I believe it provides a great illustration for how much more easy, powerful, and dynamic, if you will, using these web-based mapping tools operated through an online geographic information system, or GIS, are over a static PDF map that you might find online, or these paper maps that you may have used as an undergraduate or graduate student, or maybe in the classroom. I've always loved paper maps. I always have, always will. And these paper maps, for example, from the U.S. Geological Survey, are wonderful to use in the classroom at all levels, university on down to primary school. But they don't provide the richness, the engagement, the inquiry, the critical thinking that these dynamic maps using web-based GIS can actually foster in the classroom. So if you will permit me, let's go through a small demonstration of what I mean by that. This dynamic planet from the USGS and the Smithsonian Institution. This dynamic planet, so different and so new, was like any other.
Now, as I mentioned, one of my favorite all-time maps stemming from the time I worked at the USGS has been This Dynamic Planet, showing impact craters, volcanoes, earthquakes, and plate boundaries. Here it is on the screen. I used to spend some quality time poring over this huge printed paper edition of this map, which is still available from store.usgs.gov. Now, as you can see, this map provides some really wonderful detail of the ocean floor and these plate boundaries, and seamounts and ridges and trenches in the ocean floor. However, as you can see, this, like the paper map that it came from, is a static map. We can't really do much with it except for browse around and look at the data. Yeah, there's a key here, and there's also a back side to this map. But as wonderful as the front and the back side of this map are, as well as these cutaway diagrams, it's still just a static PDF. It's useful, but it's not as useful as an interactive map. Let's look at that next. Here is the interactive version of that same map. Note the URL here. This map is actually served inside the ArcGIS online platform. And so, what can we do with this that we couldn't do with the PDF version? Well, a lot, actually. Let's explore a couple of those things right now. First of all, we've got the ability to look at the whole world, but also the Antarctic and the Arctic, which are difficult to see at this projection. So we can investigate seismic activity at the poles. The second thing that's interesting is that we can actually turn on and off layers. And that's what a GIS, or a Geographic Information System, is all about. Being able to layer information so we can see patterns and relationships and connections between those layers. Another thing we can do is actually run queries or parameters for each one of these variables. So let's say we only want to look at earthquakes of a higher magnitude. By these slider bars here, we can just select out, for example, the 8s and 9s and 10s in magnitude. We should see a lot fewer earthquakes in that case. Let's turn off some of these other ones as well. Let's turn off the plate boundaries and some of these notable events. Okay, now I'm just looking at the 8s and aboves in terms of magnitude. Now let's go ahead and zoom in on, let's say, Alaska. Okay, now let's go ahead and look at this particular earthquake. See, this is the 9.2 magnitude earthquake that occurred in 1964, the famous Good Friday earthquake. It caused a tsunami that even killed people as far away as Crescent City, California. Now I've turned on pre-1900 notable earthquakes. And there's New Madrid shocks over 1811 and 1812, for example. And now we're looking at the volcano Vesuvius over in Italy and talking about ancient civilizations and how they were destroyed. We can also take a look at different plate boundaries and see how different kinds of earthquakes, in terms of magnitude and depth, occurred at the different kinds of plate boundaries. For example, the divergent plate boundaries have different kinds of earthquakes in terms of their magnitude and depth than the transform plate boundaries, and they have different magnitudes and depth to the convergent plate boundaries. Now, lastly, another fascinating thing about this map is that it actually has these vectors, these arrows, and these arrows indicate the direction of plate movement, and they also indicate the direction in terms of they also indicate the magnitude in terms of millimeters per year. So for example, we can see that the Pacific plate in this area is moving largely toward the northwest. And then if we look at some of these other plate boundaries, or these other plates, they're moving toward each other, hence the convergent plate boundaries. So there's a lot of interesting things we can discover about this now that it's in this dynamic mode. And this dynamic mode is made possible because behind the scenes is running a web-based GIS platform. In this case, it's called ArcGIS. And it's running all of these what we call mapping services. The impact craters, the earthquakes, the plate tectonics, the notable events, the national boundaries, the ocean floor. All that is running behind the scenes, allowing us as educators the ability to interact with this particular topic, whatever it happens to be, in this case, plate tectonics. More importantly, it allows the students to interact with this content, ask questions, think spatially, think critically about data, about history, geography, earth science in this case, and much more. So this is, I think, a good example of the differences between a static digital map, or a paper map for that matter, versus a dynamic map that's served inside a web-based GIS. So I encourage you to take a look at this and explore this dynamic planet. Thanks.